How's it going, guys? My name is Austin, and today I'll be showing you how to analyze a slope using Rocscience Slide 2018. Slope stability is an important topic within civil engineering. It can be the establishment or literal downfall of a building and can cause property damage or fatalities if not properly analyzed and constructed. In this video, I'll demonstrate how to build a slope from an example problem. From this, we will obtain a failure surface and a factor of safety for the given slope using key input parameters. After opening the program, you're going to want to find your way to the Analysis tab at the top left of the screen and select Project Settings. Here, you want to ensure that you are in the correct units. Today, we'll be using metric. Next, navigate to the Methods tab on the left of the pop-up window and select your method. Today, Bishop's method will be used. For our example, we're setting the number of slices to 50, the tolerance to 0.005, and the iterations to 75. Next, under the Groundwater tab, ensure that your unit weight of water is correct for your selected units. Then click OK. Next, go to the Boundaries tab at the top left of the screen and select Add External Boundary. Begin to enter coordinate points for your slope that are separated by a comma and ensure that both sides of the slope have enough width and depth. Anywhere from 8 to 10 meters should be sufficient. I find it easiest to start at the origin and map out my coordinates for my slope beforehand so that I just have to enter in the points. Make sure you have entered the coordinates in for any material changes and changes in the water table, then enter C to close. Next, go back to the Boundaries tab and select Add Material Boundary. Connect the line to the two previously established points and click Enter. For this example, we have two material layers. These materials must be defined by going to the Properties tab at the top and selecting Define Materials. Here, we'll be able to define Material 1 by assigning a unit weight of 16.6 kilonewtons per meter cubed. Give it a cohesion factor of 18 kilopascals and a friction angle of 20 degrees. Then moving on to material 2, we'll be able to assign a unit weight of 17.3 kilonewtons per meter cubed, a cohesion factor of 10, and a phi, or friction angle, of 28 degrees. Then click OK. Since the entire slope has been assigned material 1, assign material 2 to the bottom portion by right-clicking inside the boundary and selecting Assign Material and then Material 2. Next, go to the Surfaces tab and select Surface Options. Change the search method to Grid Search and set the radius increment to 10. Click OK and move back to the Surfaces tab at the top of the screen and select Auto Grid. Set the number of intervals in the X and Y direction to 20 to ensure the center of your failure circle lands within the grid. Next, go to the Analysis tab at the top and select Compute. Save the file and allow the computer to run the analysis. When it's finished, go back to the Analysis tab and select Interpret. This will result in a proposed failure surface according to the program. In order to ensure accuracy, the center of the failure circle should be in the grid and there should be no white spaces as seen in the box right now. To correct this, simply go back to the other window and right-click on the box to move it in the opposite direction of the white space. Recompute and interpret the slope until those criteria are met. In order to have a stable slope surface, the critical failure surface must have a factor of safety that is greater than 1. And as you can see, our slope that we analyzed in this example is safe because the critical failure surface has a factor of safety of 1.422. The resulting critical failure surface can be defined as a slope circle. This program can show you the number of slices and internal forces on them along with a heat map of how the factor of safety changes through the slope. This concludes the basics on analyzing a slope in the 2018 version of Rocscience Slide. I hope that this video has been informative and helpful in your slope analysis, and I hope that you continue to use Slide to analyze failure planes in the future. Thanks for tuning in, and take it easy.